Hello everyone, welcome to Aviation Engineering YouTube channel. Alright, so today I took another lesson regarding EASA Part 66, Module number 1, Mathematics, Lesson number 5, Graphs. Right, so if you still not watched the previous videos regarding EASA Part 66, Module number 1, Mathematics, you can watch the previous videos through my playlist. I will put the card about here, so you can click this card and you can watch these videos. And also, if you want to learn about graph type training, so I uploaded some videos, so I put the links below in my descriptions about these videos, or else you can go to my channel and you can watch. So if you still not watch the Aviation Engineering YouTube channel, please watch, please subscribe, and also please like, and please share these videos with your friends, relatives, anyone. Alright, so now let's go to the lesson. So today I'm going to start EASA Part 66, Module number 1, Mathematics, Lesson number 5, Graphs. Okay, you can see these are the graphs. Okay, now we'll go to the content. First one is graph, and secondly I'm going to talk about graph construction, and third graph and mathematical formula, and then number 4, functions and shape of the graphs, and last normal graph. Okay, normal graph. Right, number 1 is graph. Okay, yeah, so the graphs are like pictures, right? Graphs are like pictures, help for numbers, right? Graphs are like pictures, help for numbers. They help us how things related, right? To do maths faster and guess what might happen next. So there are different kind of graphs for different jobs. Okay, they have so many kind of graphs in the mathematics. So these are we are using for different kind of jobs, right? So example, pie charts. So okay, let's see the pie charts. You can see here is the pie chart. So imagine cutting pie into slices to show how much of something there is. Okay, this is, we can use the pie charts to show this kind of informations. So next one is the bar charts. Okay, bar graph. You can see here is the bar graph, right? So bar graph is like stacking blocks to compare things. So like how many points people got on a test, like this. Next one is the line graph. Okay, you can see the line graph. Okay, so the line graph, think of connecting dots to show how something change over time, right? So like temperature going up and down during a day, these kind of things we can show through the line graph. Okay, you can see here's the line graph. And so when you want to show something, just pick the graph that fits best. Okay, you can pick a graph which is best for you, and it's like choosing the right tool for the job. Okay, so that is called the graph. Okay, you can see there are types of graphs. Okay, you can see line graph, here is the bar graph, here is the pie chart. Okay, all right. Okay, you can see the examples. Here is the bar graph. Okay, and here is the pictograph graph, you can see, and this is the line graph, and here is the continuous curve line graph, continuous curve line here, and this is the pie chart. All right. Okay, now let's go to the number 2, graph construction. Yeah, before making a graph, okay, before making a graph, it's important to organize your information neatly in a table. Okay, that is very important. Before you going to make a graph, you must organize your information neatly in a table or somewhere else. Okay, so usually you will have two things you are looking at. One thing yet is changing on its own, right? That is called one thing that is like changing on its own, right? It's called the independent variable. And another thing, there is another thing that changed because of the first one, right? Another thing there is that is changing because of the first one. So this is called the dependent variable. That is called a dependent variable. So the dependent variable depends on what happens with the independent one. Okay, remember this one. There are two, independent and dependent, and the dependent depends on what happens with the independent one. All right, so the first, put your data into the table where it is easy to see, then you can start making your graph. Okay, all right. Yeah, so let's say we did an experiment, we heated yeah, okay, it's got bitter, right? okay, right. So the temperature we change is called the independent thing, and because it's what we control, and the volume getting bigger is called dependent thing, because it's dependent on what we did with the temperature. All right. Yeah. So now to make a graph, we need graph paper. To make a graph, you must need a graph paper. So we'll draw two lines. Okay, as you see here, right here, y-axis and x-axis, two lines on it, one going to side, one is side to side here, side to side, that's like the x-axis, and one is going up and down here, up and down, that is called y-axis. So the x-axis is the independent thing. You can mark the x-axis as an independent thing, like the temperature, and the y-axis for the dependent thing, right? Y-axis we can make it as a dependent, means this one is depend on the x-axis, y-axis things depend on the x-axis things. So like volume, okay, we can make it as volume, like because of temperature volume change, so the independent thing is temperature and the volume is the dependent thing. So they cross at the point called origin. Here is the origin, you can call as origin. Okay, so before we put the dots on the graph, we need to decide how much each line on the graph paper means. So then we'll put dots for each temperature and how big the volume got. Each dot shows where the two things meet up. That's how we make the graph, right? Yeah. All right. So now, yeah, don't make a tiny graph, right? Don't make the tiny graph, and look at the bigger number you put on the right side and the smallest on the left side of the graph. So find out how many squares there are on the graph paper from left to right. That is also a trick. And then subtract the small number, right? Then subtract the small number from the big one to see how much range you have, right? So divide the number by how many squares there are, and this will help you decide how many units each square on the paper should represent, right? So the good numbers to use 1, 2, 5, 10, 20, 50, like this. Okay, so this way your graph will be easy to read and won't be squished. All right, so example here, the range, the smallest one left hand, right hand side the largest one, and the 1 unit we can call as the number of units equal 1 large square. All right, okay, so now the next one, yeah, here you can see do the same thing for up and down. We will do the same thing for the side to side, and now we have to do the same thing for the up and down line on the graph. Okay, we will divide like this and call the y-axis. First find the biggest number at the top. It means we need to put the biggest number in the top and the smallest at the bottom. So subtract the small one from the big one. We need to subtract the small one from the big one to see how big the range you have. So then see how many squares there are from top to bottom. So draw your lines on the graph, one going to side and one up and down. So mark off the numbers using the scales you pick off for each axis, and this way your graph will be all set and easy to understand. All right, you can see here divided by line, okay, up and down. All right, so now yeah, now that the graph paper is ready, okay, now let's transfer the information to the graph. So it's easy, just pick one number from the independent variable. Okay, it is easy to pick one number from the independent variable like temperature and find it on the x-axis. Draw a faint line up or down from that point until it meets the line for the dependent variable like volume on the y-axis. Okay, like volume in the y-axis, here the dependent value and here is the independent value. Okay, so that is it. Keep doing this for each pair of numbers from your table until you got all your dots on the graph. Okay, so you can continue this one until you get all the dots on the graph. Okay, you can continue this until you get all the dots on your graph. Then you will see your data in the in a picture form. So the intersections represent one plotted point of the graph. You can see the intersection represent one plotted point of the graph. The procedure is repeated for each pair of value in turns. When all the points have being plotted, a continuous line is drawn through the points. Okay, when you see so many informations, then you can see some this kind of cross things over there in the graph. Then you can match it, right? Then you can see a continuous line. All right, now if your data changes gradually or smooth, okay, if your data changes gradually or smoothly like this, okay, here you can imagine here is the y-axis and here is the x-axis, right? Smoothly, like in many maths or science experiments, is better not to connect the dots with straight line. Okay, it means like if the data changes very smoothly, don't connect it as a straight line. Okay, yeah, better not a straight line. Instead, you can draw a smooth line that shows the general directions your data is going. So this helps to see if there's a clear relationship between the two things you are looking at. Okay, so instead of making bunch of connected straight lines between your dots, try to draw one smooth line that fits the general shape of your data points. Okay, one smooth line. You can see this kind of things. If your data comes like this kind of a graph, so then you try to make a smooth line like this. Okay, in the middle. Okay, here no need to go like this, and you can make it as a smooth line. So when you draw that smooth line, okay, when you draw that smooth line, it might not go through every single point. Okay, you can see, right? When you make a smooth line, you can see this one is not going very smooth. Here you can see here's the point is not going in the mid center, right? So that's okay, right? So mistake can happen when we are measuring or plotting. So what's important is that there are about the same number of points on both sides of the smooth curve. So sometimes through it's pretty clear that a straight line is the best fit for the points. That is often true, for example, simple science experiments. So if it is looks like a straight line fits the data well, you go ahead and draw it that way, right? So the goal is to show the overall trend and accurately as possible, right? Okay, now let's go to the graph and mathematical formula. Okay, graph and mathematical formula. All right, so in this course we are focusing on engineering, right? In this course we are focusing on engineering, not just maths. So we see maths as a tool to help us understand how things work, not as the main thing we are studying, right? So later on we will see that one thing changes as another thing changes, and there's usually a maths equations that connects them. For example, engineering, we might find that the drag force D changes based on the square of the air speed. Okay, example like express as a formula like D equal K into V squared. So yeah, we can show this relationship with the graph. Okay, this kind of things we can show in the relationship with the graph, and is often similar to the maths equations like y equal x squared, y equal x squared. Okay, this one you can see there's not this multiplication, right? You can see y equal x squared, where y is depend on what x is, right? Y is depend on what x is. So when we see a relationship like this, we can think of it as one thing being a function of another. So in our example, the drag force depend on the air speed. This helps us understand how different factors affect each other in the real world. So this topic is about how graph of math formula can look like real world stuff. So when we draw a graph of a math formula, so it's often make a certain shapes. The data from an experiment look like the shape on the graph. It means there are some connections between the formula and what we are seeing in the real world. Okay, all right. So yeah. So now let's go to the function and the shape of the graph. Functions and the shape of the graphs. Okay. So let's talk about different functions using simple examples. Now we are going to talk about different functions using simple examples. So the first, there's a functions called y equal mx. Okay, this is the initial one, y equal mx. So where the m is just a number. Okay, it means like m is like a number, so we can put like 3x, 4x, 5x, minus 2x, minus 3x like this. So this makes a straight line on a graph. Remember, y equal mx is a straight line. Okay, you can see these are all y equal mx, right? And in the y equal straight line of the graph, always passing through the point where the x and y are zero, right? Remember, if there's a graph is y equal mx, always is passing through the origin of this graph. It means the intersections between y and x. Okay, you can see these are the y equal mx graphs. So the number m desired, right? The number m gradient, okay, number m decide how steep or flat the line. It means how deep or how angle, it means the angle, how much deep or straight up like this. So the m is the one is deciding this one, right? So if it is negative, if the m is negative, the line goes down to the right, okay? Remember, if m is negative, if the m is negative, if the line goes down to the right, and if m is zero, the line is just sits on the x-axis. Remember, if the m is zero, it means there is no x, and then y equal m is 0, y equals 0. Y equals 0 is here, then the line is go through the x-axis, right? Okay, and the m is negative is go to the this side, all right? So now next we have y equal mx plus c, this graph, okay? Y equal mx plus c graph. You can see this graph. So c is another number. C is also another number. This formula, like y equal mx plus c, so m also number and c also another number. So here the c is another number, and it shift the line up or down. It means in here there's no c, right? So equal 1 equal mc. So in this time always this one goes past through the intersection between y and x. But in this time they have c. So now the line isn't always starting from the origin. This time the line isn't start from the origin, it can start from the c value, okay? So c is another number, and shift the line up or down. It means depend on the c, the line is shifted positive or negative, upward or downwards, okay? So it might start somewhere else depending on the value of the c. So this is a variation of y equal mx. C is a constant, and c always is a constant, and is clearly the value of y when x is 0. X is 0, then y equal m. If the x is 0, y equal m into 0 plus c. This value, it means y equals c. This value of c measured along the y-axis is known as the intercept, okay? You can see in this time the c intercept, okay? This one go through the c value, okay? Just remember, y equal mx is a straight line, and y equal mx plus c also a straight line, but it the starting point will be deviate up or down, all right? Okay. Yeah, now let's look at the another function, y equal kx squared. This is also another graph type. So first one is y equal mx, second one is y equal mx plus c, and the third one is y equal kx squared, not 2, right? Kx squared. So where the k is just a number, in here the k is a number. So this one makes a curve called parabola on the graph, right? In this kind of equations, make a parabola type graph. So when the k is getting bigger, the parabola gets taller, right? It means when the k is increased, then the parabola getting more taller, like this. Okay, so unlike the straight line we talked about before, here the slope isn't the same. It means in this time the slope is not the same everywhere. It means like in this time, in this place you can see the slope is different, and this time the slope is different, right? Same the way on the curve. So this kind of function shows up a lot in the real world situations, okay? This kind of graphs we are using a lot for the real world situations, right? You can see this is a y equal k squared. This kind of graph is make a parabola, right? Okay, now let's go to the next one. Now let's consider another type of function, is y equal kx cube, right? I mean y equal kx cube, right? So and so on. So these functions also create a curves, right? K equal kx cube means these kind of functions also make the curves, but they're different from parabola. But this kind of graphs is different from the parabolas. So they have what we call turning points, okay? This kind of graphs we have a turning points. You can see here is turning point and here is turning points, okay? Right, where the slope changes from positive to negative or vice versa. So this kind of places, the turning point in this kind of graphs have turning points, and in where the slopes can be changed from positive or negative. And here we can make a negative slope, and here is a positive slope. So however, we won't focus much on this kind of function. This kind of graph we won't talk a lot. on this course because we stick to simpler one that are more common in engineering. Okay, right, from past 66 syllabus, we are not talk about this kind of graph a lot, right? Okay, now let's go to the function y equals sine x and y equals cos x. All right, let's talk about some special graphs called sine and cosine. So they both repeat themselves over and over. Okay, these kind of things, these are sine and cosine graphs. So they both repeat themselves over and over like a pattern. Okay, so we call this repeating behavior periodic. For these graphs, the period is 360 degrees or 25 radians. Okay, in previous lessons we talk about the radians, how the radians make and how we calculate radians and how we calculate the area using the square area or something like this. So I talk about this, so you can watch this video and you can learn about this. All right, so here's the cool thing: the cosine graph start a bit ahead of the sine graph by 90 degrees. Okay, remember this kind of graph, the sine graph you start from the zero, but the cosine graph is started bit ahead from the sine graph. It is like 90 degrees ahead, right? 90 degrees ahead of the graph. So it means like 5 divided by 2, right? Radius, half a radius. So when this happens, we say that's a phase difference. Okay? It means like sine graph and the cosine graph, they have a phase difference between them. So we often see this graph in electrical stuffs. Okay, these kind of graphs we are normally used for the electrical stuff, so they help us understand how things like current or voltage change over time. This kind of graph we are using for the electrical. So when we do the electrical lessons, you can see how we use cosine and sine graphs. We are using for how the current is changing with the voltage or something like this, resistance or something like this, right? Okay, now let's go to the function y equal ex squared and y equal e minus x squared and y equal 1 minus ex squared. Okay, this kind of graphs. Okay, a little bit complicated, right? So let's talk about another functions called the exponential functions. So it's written as y equal ex. So this function is super useful in engineering too, right? This kind of graph also very useful. So it's kind of like a superpower version of counting. So instead of adding or multiplying by a constant like its irregular maths, here we are multiplying by a special number called e, which is about 2.71828. So we can round off like 2.7. So this function helps us with things that grow or shrink really fast. Grow or shrink really fast, like bacteria multiplying or radioactive materials decaying, right? So there are some other versions of these functions with slight changes, but they all follow the same basic idea. Okay, we will talk about these kind of things in the physics, right? Okay, so when we talk about the slope of the graph, right? When we talk about the slope of the graph, we mean how steep it is. Okay, how steep it is. Straight lines have a steady slope, like walking up or down a hill at the same angle, but the curves, right, can have a slopes that change, right? In the straight line have a steady slopes, but the curves don't have a steady slope. It's different at change, like going up roller coaster with a twist and turning. So maths experts figures out slopes using fancy maths called calculus, which we'll learn about later. But for engineers, slope is important because it can represent real stuff in the world around us. So we'll dive deeper into this in the physics part of this course. It means that in the physics lessons, when I talk about physics lessons, so I will talk about this graph deeper. All right. Okay. So now the area under the graph is also often used and may represent a physical quantity. Okay, when we talk about the area, so it is also useful, right? You can see the graph area under or between y equal f equal x, and the x is the axis. Okay, x is the axis. This kind of things. Okay, we will talk about later. So the area can be calculated by considering the simple shapes and the approximated. So I talk about the how to calculate the shapes, area of the shapes and volume of the shapes in the previous lesson. So in the graph, when we want to talk about the area, so we have to consider the simple shapes, right? So counting squares and using calculus, these kind of equations, we can calculate the area of the graph, right? Yeah. Now let's go to the nomograph. Number 5, last one, nomograph. Yeah. So let's talk about something called nomograph. So they are special graphs that helps us solve tricky problems involving more than one thing. Okay, remember monograph, these are used to solve the tricky problems involving more than one thing. So in aircraft maintenance, we often need to figure out how different factors affecting something. So nomograph are like super detailed map. They have lots of lines and number on turns, something on three sides of the chart, and even diagonal lines they pack with info. So to use nomograph, you need to be careful and follow the instruction. They can look pretty complicated and it's important to pay attention. Okay, you can see this is the nomograph. Okay, you have so many lines, right? So here's the example. Imagine a graph with three lines. Okay, you have 1, 2, 3 lines, right? Imagine graph is three things. So not three lines, three things like speed, distance, and time, right? Here is the speed, here is the time, and here is the distance. If you know any of these things, right? If you know, example, if you know the speed and if you know the time, you can find out their other one quickly, right? Example, if you know the speed and if you know the time, you can see the speed is here and the time is like here, and then you can see what is the distance. Distance is here, right? We can see. So quickly, so for instance, if you know the speed and time, you can find out how far you have gone. So you just follow the lines on the graph until the meet, and that's your answer. It means like if you know the speed is 250 and the time travel around 3.5, so then the how many distance you travel, approximately we can say you travel around 1000 nautical miles. Okay, 1000 nautical miles, like this. But while this nomograph is much too small for accurate computations, it can be seen when traveling at around 25 knots for 3.5 hours. So you would travel a little less than 1000 nautical miles. Yeah, you can see you can travel little less than 1000 nautical miles. So that's why in nomograph we cannot say the information exactly, but we can say like a round of very near amount. But it's very useful. If you know two informations, you can guess the other information. Right? Okay. Yeah, that is the end of this lesson. Thank you for participating in this lesson. I think this will be important for you. This is the 5th lesson. If you stick with this video series, don't worry, I will upload this next one very soon. Then you can prepare for your exam. Module 1 will be easy. So if you still not watch my previous videos, so please watch. And if you still not subscribe this channel, Aviation Engineering, please subscribe, and please hit a like button, and please share. And if you have any questions regarding these lessons, please put a comment, and I will going to reply you as soon as possible. All right, so that's all for today. Have a good day. And also the next lesson I'm going to do trigonometry is also very important for you. So then stick with my channel. I will do the next lesson, and we will see you in next lesson. Have a good day for all of you.